Hi everyone, today we're going to take a look at basic trigonometry. It sounds very complicated, but trust me, once you get the hang of it, it's quite easy. We'll start with a bit of theory, and then I'll show you how you can visually program this. Learning how to program it can be helpful to understand it better, and once you know how to use it practically, you can write cool programs with it. I will put the timestamps on the screen right now and also in the description, so if you're only here for the math or the programming, you can skip a part. Trigonometry studies the relationship between the side lengths and the angles of triangles. The most known functions of trigonometry are sine, cosine, and tangent. We can use them to calculate the length of the sides and the angles of a right-angled triangle, but we have to give an input based on other sides or angles. If you take one of the functions and input an angle, you get an output that describes the length of a side. Luckily for us, there is an easy memory aid to help us remember which output we can expect for a given input. So, K, DOA. The first letter stands for sine, cosine, and tangent. And the last two letters stands for which side you need to input or output. O stands for opposite. It's the opposite side of the angle we're giving as input. A stands for adjacent. The adjacent side is one of the two legs of the triangle that's adjacent to that angle. The one you need to choose is the one that's not the hypotenuse. That's also where the H stands for. The hypotenuse is the longest side of a right-angled triangle and is the opposite of the right angle. For example, if you take the sine of this angle, you think of the memory aid, which is SO. So that means the output will be the opposite side of the hypotenuse. You're probably thinking right now, how can I know the length of, for example, the opposite side of an angle if it returns a fraction? Well, it's easy. Suppose the hypotenuse is 1. Then sine of alpha outputs the opposite side, right? In this example, you can see that this gives us the length of BC. As a result, the x-value of point C in comparison with point B is the sine of alpha. So then, if the hypotenuse is for example 5, the length of the opposite side of alpha is the sine of alpha times 5. This is because sine of alpha will always output something with hypotenuse 1, but in this example that's 5 times too small, so multiply it by 5. An important thing you need to know with trigonometry functions like sine, cosine, and tangent is that the input is in radians, not in degrees. When you work with degrees, you go from 0 to 360 degrees to get a full circle, but when you work with radians, you go from 0 to 2 pi. This is because the circumference of a circle is 2 times pi times the radius of the circle, or simply pi times the diameter of the circle. To convert degrees to radians, we just do the angle in degrees divided by 360 times 2 times pi, or simply the angle in degrees times pi divided by 180. You can also invert trigonometry functions. For example, if you know the length of the adjacent side of an angle and the length of the hypotenuse, you can use them to calculate the angle in radians. For that, you don't use sine, cosine, and tangent, but you use arcsine, arccosine, and arctangent. These functions are visually represented in the unit circle. The unit circle is a circle with radius 1. Very important thing to remember is that a right-angled triangle can be used to draw a circle or to draw a specific angle. You can now see on the screen what the connection between a right-angled triangle and a circle is. The radius of the circle is also equal to the length of the hypotenuse. By using sine and cosine of the angle, you can determine where the point is in Cartesian coordinates. Cartesian coordinates use x and y, while polar coordinates use an angle and a radius. The more the angle increases, the further the point goes counterclockwise on the unit circle. If you then plot, for example, the y value on a graph, you get a sine wave, vice versa for the x value and a cosine wave. To use all these cool functions on a calculator, you can use the buttons sine, cosine and tangent, and for the inverse versions you press second and then the same buttons. You get sine to the minus first, cosine to the minus first, and vice versa for tangent. So the theory out of the way, let's get into programming. Okay, so I set up a PyCharm project. If you don't have PyCharm and use another IDE, or if you use the default Python IDE, it's called idle, it's no problem, you can still follow along, but I'm expecting you to already know the basics of Python. So we'll start with the modules that we are gonna need. We're gonna need Tkinter for the visuals, also math for sine, cosine. We're not going to use tangent in this one, and also time, because if you do something with animations, which we're gonna do, you need time.sleep, because otherwise, if you have a good computer, it will calculate it way too fast and show it way too fast for us to see it, and we don't want a unit circle that's rotating way too rapidly or changing the angle way too rapidly. So what are we going to program? We're going to program the thing that you saw in PowerPoint. For that one I used a GIF from Wikipedia because I thought it was a really good one. The one that we're going to program is obviously not going to be that good, but it will still be good and fun to play around with. I'm going to keep it simple for this tutorial. So we'll start with a little bit of constants. Of course we're gonna need a canvas, so I'm gonna make constants for the width and the height so that we can give them in our canvas function. So with Tkinter we first need to make a tk object, or a root some people call it, but I like to just use tk. Then we're gonna create a canvas object with the width and the height, our width and our height. The reason that I don't put these numbers in here is because we're gonna need the width and height later, and if I'm always writing 700, then I want to change it, well, I would need to change all the 700. And then we're gonna pack the canvas because otherwise we can't see anything. Then I'm gonna make our main loop, gonna be going on forever until we close the canvas. We're gonna need an update and time.sleep. Again, time.sleep is so we can see the animation and it will always go about as quick. We will put a constant in here that we write also here. I'll set it to 0.005. If you have a very good computer, you can set it a little bit higher so you can see what's going on, or if you have a slower computer, you can set it, for example, to 0, because the calculations will already take a lot of time. Then we'll set an angle to 0. It's gonna have a radius. I'll set it to 100. Then here we need to convert the angle to radians, and like I explained, to convert it we need to do the angle in degrees, which it's already, do it times pi and divided by 180. To use pi in Python you can just use math.pi, but you always need to make sure, of course, that you have the math module imported. Then we're gonna have an x value. I will set it to none for now. A y value, and we're gonna draw the triangle that you also saw in the GIF that I showed you. So this triangle we're gonna draw with Tkinter again. To draw something with Tkinter, canvas, create polygon, and then we need to give the chords. Triangle has 3 points, so I will put 3 tuples in a list. One of the points of the triangle needs to be in the center of the screen. What's the center of the screen? Well, it's the width divided by 2 and the height divided by 2. Of course, you can, after the tutorial, while we're doing the tutorial, change some of the things for your personal preferences, or to play around with it. Then the second point we'll set to be the upper right point. That's completely gonna depend on x and y, so it's exactly the same, but we're gonna add x and add y to it. Then we should already calculate x and y maybe. So x is equal to the radius. The radius will be the length of our hypotenuse times met.cosine, because x is almost always cosine of the radius, not the angle, because the angle is in degrees. We'll treat it like degrees, but in radians. Y is exactly the same, but sine of radians. If you don't know anymore why it's cosine and why it's sine, you can check out the tutorial from the beginning of the video. And the last point of the triangle will be we'll have the x value of the upper point and the y value of the static point. So the x value will be this, because it's from the moving point, and the y value will be from static point, like that. Okay, if we run this, nothing is happening. Why? The angle is not increasing. So our angle needs to increase, of course. And now we can see that something is already happening. There are two problems, or maybe more than two, but for now there are two problems. One of them is that the triangle isn't disappearing. So after we update it, we should delete the triangle, like that. Now we have a beautiful rotating triangle. Maybe it's a little fast, so we'll make the sleep time. But the triangle is completely black. It doesn't look that great. So to make it so it doesn't have a fill, we're gonna set the fill to nothing, and we're gonna set the outline to simply black. That's much better. It's a little bit thin, so I'll make the width 2. The width is normally 1, but now I'll set it to 2, like that. Now you can already see that the point that's most moving so in the x and the y direction is drawing out a circle, but we don't see a circle. So we're gonna make it so it will draw a circle. Of course, once it has done one loop, we don't want it to override itself and keep drawing a circle, because there will be way too many objects. So here we'll check if the angle is smaller than or equal to 360 degrees. That's why we use the degrees, also because we do +1, and otherwise we would be way too quickly at 2 pi. Then we need to create a line, draw a line between the last point and this point. Why not draw points? Is because then you would have a total circle. If you want that, you can totally use points. For points you should use oval and then a little bit of a radius, but that's not what we're gonna do in this tutorial. I will create a circle that looks like a circle and not a dotted line. The only thing is we need to also have the previous chord, the previous coordinate. So here we'll set the previous x to x and the previous y to y. The only problem is that the first iteration there won't be a previous x and a previous y. You could set it here, but to make our lives a little bit easier, we'll just say and the angle needs to be greater than or equal to 1, so it needs to already have done at least one iteration. There are better ways to write this, that's why it's underlined, but I'll keep it like this, very simple. And we'll create a line between previous x previous y, and x and y. There's a problem with this, and you'll see what. The circle is drawn at the 0, 0 point. The 0, 0 point is with the inter here. So the 700, 700 point is here. So what we need to do is add this. The same with height, like that. So it will start in the middle of the screen. At the middle of the screen. Like that. The circle again is a little bit thin, so I'll set the fill the fill to red because it looks better, and the width to 2. Also, to make it a little bit more readable, we'll put it in a list and also into tuples, so we can see points separated and the x and the y separated. That's a little bit more readable. Like that, we already have a nice effect. And here it should stop the drawing. Then, that's already cool. That's a unit circle. But now we want to add a sine wave. So for the sine wave needs to also move to the right. And to do that, we need to make an array of lines. We'll also add a constant x speed, which we'll set to 1. The x speed will be the amount that the sine wave moves to the right in each frame. If you don't get this immediately, it's no problem, you'll see it in a second. So here we'll draw a line for, again, a line, not a dot, because otherwise you have a dotted line. Again, the same thing, the angle needs to be already greater than or equal to 1. There are better ways of writing this, but I'll do it like this for now. Okay, so we'll draw a line on canvas, and so we'll create the line, and the line also again has 2 points. The 2 points should always be at the same x value, because we're only looking at the y value, so we can already fill in the x value. We could say at the center, but that would look a little weird. It's better if we add the radius to it. So it will draw at the edge of the circle. The height of the line will depend on the height of the sine, the height of the point that's moving around the circle. So it's actually exactly the same height, and it will go from previous y to this y. One thing again, very important, not previous y, but I almost forgot it, height divided by 2 plus previous line, like that. And we can see we get this beautiful line. Only thing is, it's not moving. We'll append the line to lines, so lines to append line, and then in every loop we'll say for I, lines, enumerate lines. Why it's enumerate I will explain in a moment, and the I also, I will call it line, like that. And then we're gonna move the line to the right. To move something to the right, we need to increase its x. So we're gonna move the line with x speed. X speed is already positive, positive is increasing, and the y value is 0. So move this body or this object with this x velocity, which will be 1, and this y velocity. So what do we get now? We get this, which is already quite beautiful. There is a mistake though. So there are a couple of things that I want to change in a minute, but here the y will always be the same. So what I want, the x I mean, what I want is that it will be connected throughout the whole wave. So what we're gonna do, maybe this doesn't sound very intuitive, it's very intuitive to you, but we're gonna add the x speed to the second point. So now it looks way better. Then we're gonna make the fill green, like that. Now the only thing is that the longer you let this run, the slower it will run. You can already see it happening, because each line of these is still rendering out of the screen if it's going out of the screen. So how can we prevent this? Well, it's very easy. That's why I kept this. We will only move the line when it's still on the screen. So we'll say this. So canvas.chords will return the coordinates. We'll take the x coordinate, and if that is greater than the width, we'll delete it. Delete line, and we'll also delete it from lines. Therefore, I enumerate is both first the index and then the object. And then else, we're gonna move it. You can see now it's not slowing down that much anymore. Now this is quite slow, but again, we can change this. Now it will go a little bit faster. Now it should go at about a constant speed. And then there's one more thing that I want to do, and that's to add a connection line. Like you can see, when we run it now, there is a gap in between these points. It's the same y value, but it still doesn't look connected. So we'll add a connection line. We'll do it here in this if statement, because again, it needs to come together with these lines. So we'll create a blue line that connects the first point of this one with the upper point of the triangle. The upper point of the triangle is this one. Like that. It should work. And as you can see, it works. There are two things. It's not blue and it's not disappearing. So we'll make it blue. Fill equals blue. Better. And we'll make it disappear. So we'll just say here again, if angle is greater than or equal to 1, we're gonna delete the connection line. Like that. Oh, connection line is not defined. Okay, so what I did was refactor this a little bit, so it is in a little bit of a different order. You should check if this is in the same order in your project, and then everything should work, and you have a beautiful sine wave in a unit circle. And that's the beauty of math. Now you can also play around a little bit with the values. One thing I want to say is the reason why it's going clockwise, while I said in the PowerPoint that it would go counterclockwise, is because in Tkinter the y value here is 0 and here it's 700, while when we're talking about math, normally the y value is increasing when you go up and not down. So you could flip that for yourself. I'm not going to do it in this tutorial, but the tutorial is finished. A couple of things I can show you is, for example, if you halve the radius, you can see that the sine wave will be way less high, and if you double the radius, you can see that it's a really large sine wave, and also a large circle, of course. And if you increase the x speed, for example, to 5, you will see that it's really spread out. And if you change it, for example, to 0.1, you'll see that it's almost like steep cliffs. You can play a little bit with it yourself. I hope you enjoyed this video. If you did, please leave a like, comment and subscribe. And I hope I see you in the next one. Bye!